Welcome to educator.com. This lesson is about power rules. In this lesson, you will learn to use power rules. Applications are multiplying large numbers and finding the surface area of the Earth. Let's review the vocabulary. An exponent is the number of times a base is used as a factor. Now, if you had 3 to the 7, the exponent would be the 7, and the base, or the factor, would be 3. A power is an expression using a base and an exponent. So in 3 to the 7, this entire unit would be called the power. Raising a power to a power. To raise a power to a power, you're going to multiply the exponents. Be careful of the difference between multiplying powers and dividing powers. Those four rules, raising a power to power and later raising a product to a power, you're going to have to keep very separate. So here we have a to the m raised to the power of n becomes m times n. So for example, if I had 3 to the second power raised to the third, I would multiply 2 times 3 and have 3 to the sixth. If you weren't sure about the rule and you didn't remember what to do here, you could always take this exponent 3 and expand this 3 times. So you would have 3 to the second, 3 to the second, 3 to the second. So here you can count. You have 1, 2, 3, 4, 5, 6, 3 to the sixth. Be very careful to keep this different from 3 to the second times 3 to the third. Notice in this problem, you're raising a power to a power, whereas here the bases are being raised to the power and you're simply multiplying the bases. And in this example, you would be adding the exponents. 3, 2 plus 3 is 3 to the fifth. If you're having a hard time keeping these rules separate or clear in your mind, just remember that you can always write it out. You can expand it. Such as here I expanded it. Then I was able to count and find the exponent 6. In this one you could also expand it. And then you would see that you have 1, 2, 3, 4, 5, 3 to the fifth. Let's try raising a power to a power. 6 to the third to the negative fourth. 3 times negative 4 is negative 12. 5 to the negative second to the negative fifth. Negative 2 times negative 5 is positive 10. Raising a product to a power. Now once again, this is different. A product is two numbers multiplied, or variables and numbers multiplied. When this happens, it's sort of like distribution. The m power is going to go to the a, and the m power is also going to go to the b. So you're going to have a to the m, b to the m. So for an example, if you had 3a to the second power, you would multiply 3 to the second and a to the second. And that might simplify to 9a squared. So once again, if you're finding the rules difficult to remember, you can always write it out. 3a times 3a, because it's to the second power. And 3 times 3 is 9, and a times a is a squared. So remember that with all these exponent rules and power rules, you can expand them if you've forgotten the rule. Let's try raising a product to a power in a word problem. Use the formula for surface area 4 pi r squared to find the surface area of each object. We're going to use 3.14 for pi. Let's find the surface area of a plant cell with the radius of 3 times 10 to the negative fifth meters. So a very small cell. So the surface area is 4 pi r squared. So if I substitute in here, I'm doing 4 pi, and this is 3 times 10 to the negative fifth squared, because it's r squared. So I'm going to first multiply 4 times pi, 3.14 times 4. 4 times 4 is 16, 4, 5, and 12. With two places. So I have 12.56, and now inside the parentheses, 3 times 3 is 9, and 2 times negative 5 is negative 10. Now I need to multiply my numbers here. So I have 12.56 times 9. 54, 45, 50, 2 times 9, 18, plus 5 is 23, 9, 10, 11, with 2 places. So 113.04 times 10 to the negative 10. This number multiplied with this number is not significant enough to change the place value here. So we remember that in scientific notation, though, your decimal always has to come after the first number. So if I'm moving it twice, I could say this is about 1 times 10 to the second if I want to estimate this out to 100. So if I take 1 times 10 to the second, I'm going to say 1 times 10 to the 2 minus 10 is negative 8. So the surface area for this plant cell is about 1 times 10 to the negative 8. Now let's look at the moon with the radius about 1.1 times 10 to the third. I'm going to have surface area equals 4 pi r squared, which is 1.1 times 10 to the third squared. Well, luckily I've already done my multiplication for 4 pi earlier here. So that's 12.56. I'm going to multiply that with the 1.1, which is going to be squared, and then 10 to the third, which is 3 times 2 is 6. So 1.1, let's do that on the side. Two places, 1.21. So 12.56 times 1.21. We have 6, 5, 2, 1. Hold the place, 12, 10, 11, 4, 5, and 2. And then hold the place, 6, 5, 2, and 1. 6, 7, 9, 11, 5, and 1. And we have 1, 2, 3, 4 places. 1, 2, 3, 4 places. I'm just going to go ahead and round it right now. Instead of 15.1976, we're going to use 15. So 15 times 10 to the 6th. And remember that your decimal place has to come after the first number. So 1.5, this equals 1.5 times 10. And this is like a little imaginary 1 here, so I'm going to add this 1 with this 6. So it's going to be 1.5 times 10 to the 7th. And let's remember our units. This is meters, and this is miles. All right, let's try a little simpler example. X to the negative third raised to the negative fourth. We're going to multiply. Negative 3 times negative 4 is positive 12, x to the 12th. Let's complete this inequality statement, and we're going to do that by solving each portion. So let's compare. Remember that when you're multiplying two powers, you add the exponents. So 5 plus 7 is 4 to the 12th. And when you raise a power to a power, you multiply the exponents. So 5 times 7 is 35, 4 to the 35th. So obviously it's easy to see here that 4 to the 35th is greater. Find the area of a square whose side is 4.5 times 10 squared centimeters. Well, we need to remember that the area of a square is side times side, or side squared. So let's take a side, 4.5 times 10 squared, and square it, and that will give us area. So I'm going to do 4.5 squared and 10 to the second squared. 4.5 times 4.5 is 25, 2, 20, 22. Hold the place. And then 20, 16, 17, 18. 5, 2, 10, and 1. With two decimal places, 20.25 times 10 to the 2 times 2 is 4. But wait a minute, we need to make sure that our decimal is after the first number. So this would translate into 2.025 times 10. Well, you have a little imaginary 1 here, so now let's go ahead and add the exponents. 2.025 times 10 to the 5th. And remember that we're looking for area, so this is going to be centimeters squared. You were multiplying centimeters times centimeters. So when you did the side, you went 4.5 times 10 squared centimeters times 4.5 times 10 squared centimeters. So you were also not only multiplying 4.5 times 4.5 and 10 squared times 10 squared, you were also multiplying centimeters times centimeters. That's why in area, your unit is always squared. Find the area of a circle with the radius of 3 times 10 to the negative 4. Use the formula area equals pi r squared. And we're going to use 3.14 for our pi value. So first I'm going to do some substitution. 3.14 times 3 times 10 to the negative 4 squared. So let's expand that. 3 squared is 9, and negative 4 times 2 is negative 8. And then we're going to be multiplying that with 3.14. So 3.14 times 9, 27, 28, and 2 places. So 28.26 times 10 to the negative 8. However, I need my exponent to come after the first number, so that would be like it was equaling 2.826 times 10 to the first power. So let's take that 2.826 and let's take that 1 and go ahead and add it along with the negative 8, which will give us negative 7. So our area of the circle is 2.826 times 10 to the negative 7 inches squared. And that will give us the area of the circle. Thank you for watching educator.com.